Hi, my name is Milton Gary. Welcome and thank you for joining us for the opening of the third customer collaborative space, the USA CoLab. Today is a very exciting time in automation. It is also a very important time, with an estimated 900,000 open positions in manufacturing in the US alone. Manufacturers, distribution and logistics centers, agriculture and food service professionals are looking for ways to keep their workforce safe, to make their operations more efficient, and to free valuable human capacity. Established first in Germany and then in China, the CoLabs are another way that Schunk aims to support the adoption of automation. To give some orientation, we are in our headquarters in Raleigh, North Carolina. Our well-known training and tech center is off to my left, and our newly renovated CoLab is in the front to my right. Before we move on to the CoLab, a few words from our CEO, Mrs. Christina Schunk.
Greetings from our CoLab here in Brackenheimhausen, close to our crimping system production location, and a very warm welcome. In the middle of the crisis, at the beginning of 2021, we decided to establish another milestone in the company's history. And we opened a validation center. The CoLab has been a great success right from the beginning, and up to now, more than 200 validated customer applications speak for them. We help customers to make their decision easier to automate their applications, and we support them in another and effective way to work more cost efficiently. The feedback from our customers is a very positive one, and our performance, or in other words, our new portfolio, is a real added value. The very successful introduction of the CoLab concept motivated us to roll this concept out on an international level on our locations worldwide. And today, I'm very happy to hand over the key to our dear colleagues. We will offer there the same services as in the headquarters in Germany. A wide range of robots, experienced application engineers, a broad network of system integrators and other technology partners. Dear CoLab team in the US, we wish you great success, and we are looking forward in working with many customers, partners and guests in finding the best automation solutions for challenging applications. Let's move. Stay healthy, take care, and thank you very much.
Thank you, Mrs. Schunk, for that warm welcome and those encouraging words. I would like to introduce Tom Reed, Vice President of Automation, and the manufacturer, Jay Call. And maybe we can start by, Tom, can you give us a few words about the vision for this lab?
Sure. Thank you for joining us on our big day, launching CoLab in the US. This space was designed to be an active workspace for engineers and other industry professionals to work with Schunk engineers to be able to qualify and work out applications that are challenging and uncertain, to be able to prove them out in advance during the planning stages of their application projects. And we've seen that recently there's this growing trend where many new users of automation are trying to enhance their manufacturing by employing automation processes. So CoLab is a great tool to allow these individuals and organizations to be able to prove out and to gain confidence and experience in the process before making big investments. At the same time, companies like Schunk are pushing forward development of componentry technology so that even advanced people that are used to doing automation, they can take advantage of advances of components and to be able to test them firsthand to see if they're right for them.
Absolutely, and that's just the biggest thing right now that we're in the industry. There's so many first-time users without automation. We're facing a massive labor shortage. We're facing a massive skill gaps. So what we need to do is leverage automation to equip small to medium-sized manufacturers and also large automation companies as well to take advantage of these systems. And what better place to test their processes of what they want to automate before they do any type of purchasing.
Yeah, that's exactly right. Tom, what do we have to show today?
So we had a lot of cool things to show. So there's several applications that are set up. We have 6 robot platforms where we have a variety of being able to test new technologies of gripping. And we also have some different innovative processes where a company that might be having a barrier to automating something, we can show them how to make those through an innovation to be able to make those processes easier. So we'll go through them just step by step, starting with the one closest to us.
Excellent. Perfect. Sounds great. Let's check out this first station.
So first off, in our CoLab, CoLab is designed as collaboration with customers and engineers at Schunk. A great vehicle for doing that collaboration is CoLab.
Collaborative robots, right?
Exactly. So it gives us a safe environment where engineers like Brennan can build up equipment and be able to operate them and prove out functionally that they will work. So in this first application, we're showing a tricky process that involves taking an O-ring and assembling it to a shaft.
Yeah, absolutely. And the one thing I found out about O-rings is the first O-ring was actually invented in like the 1890s. So O-rings have been around for a long time, but the technology to automate assembling them instead of doing a hand process is actually pretty unique. Can we walk through what we're looking at here as a station?
Absolutely. And yeah, think about that hand process. Isn't that is the worst job to do ever, to think about workplace injuries and inconsistencies of parts is the last thing you want to be doing by hand. It's a great application to be doing in an automated way and freeing up operators to do better tasks. So what we're going to start showing off here is just simply we're going to put the O-ring into a gripper. And this part's pretty simple and generally accepted, not very difficult thing to do because the gripper fixture itself, it moves, the fingers can move in and out and be able to grasp the O-ring easily. But if we wanted to set up a CoLab project just to grasp the O-ring, we could do that separately. What we are going to show is the more complicated thing about actually inserting it onto the shaft.
Yeah, let's take a look at it.
So here we have it set into the assembly. We're going to open up our gripper jaws. Now we have it spread wide so that the part can be presented to the O-ring. So Brennan, can you bring the robot down, please, and bring it into the position?
So while this is coming over, one thing I noticed is it was a 2-position opening. We opened it first up. There are 3 points that almost made a triangle, and then a second opening that did the other 3 points. And this is being done because a lot of times when we're assembling O-rings, we're worried about rotation or it rotating internally on the component or on the part itself.
Yes, exactly the case. So one area where even savvy, experienced users of O-rings really struggle is in that exact aspect, is where when you put it on, if you try to strip the O-ring off and push it on, a lot of times it's going to furl, it's going to rotate and not align or be seated properly. And that's the last thing you want to do is then not find that, have it go into a part and have that part fail on you because of an improper assembly. So the reason that we developed our gripper this way with alternating fingers, it does 2 things. You'll see here in a second how it assists in the assembly, but it also allows for other types of applications where we shrink the O-ring to be able to get it inside of bores. That's a project for a different day.
So not just OD, but ID insertion applications as well.
Yes.
So as we attach this part to your component, what are the size O-rings that we can work with here?
So for the CoLab, we have the gripper set up with standardized fingers that are
And that's what we
designed.
see here on this board. We have all these different fingers that can handle different diameter parts.
That's right. That's what they're there for, just so that we have them ready to go as applications arise. So these are set up to handle rings from about a 1/4 inch in diameter up to about 5.5 inches in diameter.
Okay, so pretty large O-rings.
That's right. And of course, for things that are outside of that range or different, more complicated O-rings, we could always custom machine or 3D print fingers on a case-by-case basis.
And that's the awesome thing about additive manufacturing. I noticed you have 3D printers in the CoLab space. So if you need something unique, you don't always have to go to subtractive manufacturing. You do prototyping. You can leverage 3D components to do your prototypes.
Exactly right. So Brennan could draw something up at 5 o'clock, come in the next morning, and
And
it's
it's
got his
ready.
fingers ready.
Perfect.
So here we'll just keep going here. So we'll go with the assembly. So what's happening here with the fingers, we are releasing individually.
And we drop our
And
fingers, right? So we go in, we're gonna drop our fingers.
And so, yeah, so if we drop our fingers, what's happening now is that the O-ring snapped into place into 3 different pinch points into the groove of the O-ring. So now if we just simply remove it away from the gripper, now it's already in place, it's seated in the right position. So pulling it away is not going to cause it to rotate as we were concerned about.
Awesome. Well, thanks for this demonstration of ORing Assembly.
Yes, thanks.
Appreciate it. All right.
Great to meet you. So next in the process, I'm going to hand you off to my colleague, Corey Razor. Corey is an expert in cobots, and he's going to show you a new technology called adhesive gripping.
All right, let's check it out.
Thanks, Jim.
Hey, how you doing?
How you doing? Nice to
Good.
meet you.
Yeah, thanks for being here with us today.
So what are we looking at here? There's something I noticed right away. There's no air
There's
on
no,
this robot.
so this cell here is our proof of concept station for our newer technology, our KISO gripper. And what we find out there in the industry is there's all these flat parts that are maybe sometimes pretty thin and wouldn't be ideal for a mechanical grip. You would initially sort of lean towards thinking vacuum or suction cup would be the ideal. But for some reason particular to that part, there may be issues even with vacuum. So a great example is, this little chip here, and remove it. You and I can see, but I'll have you show it to the camera. This is pretty perforated. It's kind of, porous.
Yeah.
And to do that with a suction cup would be quite challenging.
So-
You'd have
so-
to pull a lot.
So I'm gonna bring this up to the camera here. So there's a lot of holes inside this PCB board, and normal air is not gonna work, or you're gonna have to pull a bunch of air. You're gonna have to
You'd
pull
pull
a
lot.
crazy vacuum. But if I just go down with my end of arm tooling or this adhesive gripper, I can now grab that component and it automatically holds it. I can invert it. And then a very simple way is I can just then, there's actually a decent amount of force to
There
pull that
is.
off, pull it off that way. So on the camera, it's really hard to see this. So you have another one over here that has a much more coarse setting. Now that one had like 10,000 hairs. And what are the size of those hairs?
Yeah, so they're going to come in a couple different configurations that we can do as a standard. I believe it's 700 micron length hairs, 50 and 25 millimeter micron hairs. And that's kind of where the variability or ambiguity comes into the situation, right? So we see that this one is great at handling this piece,
Yes.
but it may not do well in our demo on these smooth, flat pieces. So that's where testing is so important. And with our CoLab here, we've got the resources that, manufacturers can come in, they can bring their parts, we can work with them and sort of prove out the system beforehand and build their confidence that,
Absolutely.
if they invest in the robot, and if they invest in the tooling, they're going to see success.
And one thing I think I see here right away is I see watch covers. So screen handling material that immediately come to mind, right? Because you don't want to put any impressions or suction cups or, every suction cup is going to have a little bit of material that's left over, build up a product. You want to keep that surface as clean as possible.
That's absolutely right. That's one of the great things about the KISO gripper is, not only does it not need air, it doesn't need electricity. It does a really good job of not imparting any residue, oils, films, or anything like that on the part. So screens,
Yep.
Things that you want to have look professional, very clean to present, or things where it might inhibit the process, like silicon wafers and
Yeah,
things like
electronics especially.
Yeah,
Right? We have very delicate components we want to handle. And the fact is, it doesn't take much force to grab on
Not at all.
and get control of the product. But then removing it, it can be done, it looks like either some sort of rotation
Yep.
or some sort of a shear process that removes the.
Yeah,
the
so
product.
typically any form of shear is going to work, or any form of sort of tilt. If we kind of strip it in this direction, that will also release it.
Perfect. So this is the adhesive. I mean, it reminds me of a gecko with its fingers, right? Or a frog being able
Exactly.
to climb up a tree. It can grab onto these crazy surfaces that you normally might not be able to with a standard pitch point gripper.
Yep.
Or, in this case, holes that, air would leak through a suction cup.
Yep, exactly, and that's where the technology was inspired from. So it's definitely a pretty neat new technology out there.
Perfect.
So with that, I'm going to go ahead and hand you over to our seasoned application engineer, Michael Malaya.
Awesome.
He's
Well,
going to
appreciate it.
he's going to talk to you about some efficient ideas and material removal.
Very good.
Fantastic.
Michael, how you doing?
Good to meet you, Jay.
So the first thing I see to your station is, I think all of us know this too well, this handheld deburring application. What are we looking at here? Because honestly, right away, this robot's a lot more attractive to me than this handheld.
Certainly. And why would that be? That's a manual tool where you have possibly a cast part, semi-machine part with a lot of sharp edges. These are burrs around the edges. You would take a tool like that and manually your hand
go in there and clean
all these
each
edges
individual
yourself,
edge.
varying pressure with your hand, very manual, labor intensive process, prone to repetitive stress injuries from hand injuries. It's not the easiest job to get somebody to want to do either. And in this time of a labor shortage, you really do want to make your jobs as attractive as possible, something that somebody I might actually want to stick with. So what we're trying to do and what we're proving out is an automated process for deburring in this cell. This is our material removal cell. We could look at deburring, we could look at polishing, sanding, filing. We have different tools that could do all that. But in this case, we're doing a edge break. So if you machine a cast part, or if you have just a raw cast part, you're going to have flash or some kind of sharp edges on all those edges of the part. Those can cause a dangerous environment for anybody handling it, for packaging, and for longevity of the part. So you have to remove those burrs. Now, how do you do that? As you can see, there's a very intricate holes. Up until very recently, this had to be a manual process. How else would you do it? Only now with things like our CoLab, we're testing out processes where we could do this in an automated fashion. In this case, using a collaborative robot and a tool so that we can have an iterative process of trying out different pressures, different tools to see what accomplishes what the customer wants most.
And that's one thing I always think about when there's a lot of companies who are looking at automating for the first time. They view that there's a risk. Can a robot repeat the quality of the operator that's doing these tasks? I think that's one thing when you look at is right now in the industry, there's 800,000, 900,000 open jobs in the manufacturing space. And what can companies do to stay competitive, but also be able to push out the product that they're getting orders for?
Right.
There's so much manufacturing right now happening in America, but one thing they're facing is there's not enough labor to be able to complete all the tasks, to be able to push out parts. So we can take a robot, and it's not necessarily a collaborative robot, it could be an industrial robot in itself. And we can then take that and take this very manual process that, let's say, so no one wants to do 8-10 hours a day.
Has to be done, no one wants to do it.
And we can take that operator and put them on a more purpose-driven task
Exactly.
that they're going to enjoy. And really what they're doing is there's a couple of things that are happening. One is labor retention is happening right now because a person's going to stick around a lot longer when they can do something that they're enjoying a lot more.
Absolutely.
And that's so you're going to be able to attract a lot more people as well to your company because you're automating what before once was a very labor intensive. Because I know my wrists after doing this 8 hours a day, there's no joy in that.
And the true value of a human operator in a process like this is the intelligence, the approach to how do we approach, not necessarily the physical process that a machine can possibly now do.
Yeah, but the approach to it, I guess one thing that this CoLab space is bringing to a lot of manufacturers is they can come in here and test what that process would look like. Test, can I use an automated deburring system that will be able to clean up my product before I purchase it?
Absolutely. That's exactly what we're trying to show here. And
Perfect.
the customers have absolute confidence in our ability to build a fixture, send us in our parts, and we'll work with them to make sure that we have a provable process that they can implement in their facility.
Awesome. Well, thank you very much for showing me this. I appreciate
Absolutely.
it.
Thanks for coming by, Jake. I'm going
Thanks,
to
Mike.
throw you to my colleague, Blake Hall.
Perfect.
Other application engineer.
Blake Hall. Well, that name sounds familiar.
I
I'm
know.
Jake Hall.
Jake Hall.
And we have
Good to see
absolutely zero relation together, but it's still a last name. You got to make a joke in there.
Yes,
somewhere.
absolutely.
So what are we looking at here? What's this application?
Yeah, so what we're going to look at over here is kind of a marriage between our world of automation, robotics, and then this classic machine tending. So what we've kind of approached is for a long time, there's a lot of skill that's out on the manufacturing floor. But one thing that doesn't involve a lot of skill is taking apart, putting it in a vise, turning the manual vise, sitting back, letting the process go, coming back over. So the first thing that we're going to attack here is just using a robot. That robot can be your arm. So we're going to take a gripper, we're going to come in, load that part for us.
And the one thing, as we're looking at this, let's zoom in here right now. So there is absolutely no air that is being guided outside underneath this table to this component. So the air is being driven through this end of arm tooling into this, and what are we calling it again?
Yeah, exactly. So that's what we're gonna jump into here. This is Tandem Unleashed.
Tandem Unleashed.
Yes.
Now, I just think of where the machining shop, that's just something Titan Gilroy would say, boom, Tandem Unleashed, you know, and with this industry. And that's one thing that's really interesting. There's 14,000 machine shops here in the US, or 14,000, 18,000, some crazy number. And let's face it, operators standing around all day or waiting for another machine to process where they have to push a button to open a grip or re-grip something. And that's just something that doesn't drive value. And that's what this is addressing.
Exactly. And that's what we're kind of trying to accomplish here in CoLab. You know, this is a space for great ideas and great innovation. And that's what we saw here. You know, we can bring a robot over, do this, do that. But if there's no air in that CNC machine, you know, what are you going to do? You still have to have somebody over there, turn the device, whatever it may be. You might have multiple axes. You don't have room for that air to flow. So what we've done is we've just simply brought this little coupling in that can just sit in your mill. Your robot's going to do all the work. It's already bringing air from outside of the CNC machine, and now it's going to bring that straight to our pneumatic device.
And we're really being able to have the ability to drive out a lights out operation. I can have my components outside the machine that I need to bring inside, do some processing, go in, grip the chuck, unlace the chuck or the gripper, and be able to run that without any human interaction.
Yeah, exactly. You come back the next morning, you've got a cart full of parts waiting for you, you're good to go.
So this is really another tool in the automation process for material handling and machining that's going to allow manufacturing companies and machine shops to do fabrication of components without the need of an operator standing by that machine.
Yeah, and no matter how big or how small that operation is, you know, we're here to help out every single machine shop we possibly can.
And that's the whole thing too. It's not that that operator is going somewhere or not being there anymore. It's now that operator can do 3 or 4 other things. And that operator can learn, now I can program a robot to do this task. I can program a robot. And what we're doing, we're creating more value for that operator, that they're learning new skills. They're not just being a machine loader or a CNC programmer. They're becoming someone that can handle, you know, program robots as well. And that's the one thing. In the United States right now, there's 300,000 robots in the United States alone, a 17% increase in robotics this year. It's just some crazy numbers where robots are a tool to help alleviate really the job shortage that many machine shops are facing.
Absolutely.
Perfect. Well, thanks so much for showing us. Any other highlights that you wanted to point out?
Hey, no, not really. I mean, we've got a lot of flexibility built into our tooling here. So, you know, it may not just be that a gripper on the end of that robot wrist is going to fit into your cell. So we've got some custom components here where we can build this in the barn tooling up with some valving. You know, we can do it all. So just depending on the customer situation, we can bring a solution to them.
Perfect. All right. Thanks so much, Joe.
Absolutely, Jake. So we're going to turn you over now to Matthew Smith. He's going to talk to you about magnets.
Awesome. Fantastic.
Jake,
Hello, Mr.
Good
Smith.
to see you. How are you this morning?
Doing good.
Good.
So what are we looking at here? I see one thing right away. I see a robot and I see magnets. That's something new that we haven't looked at the line yet. What's making this go? I mean, because I love magnets. Magnets are so much fun to play with, and they can solve a lot of unique applications.
Oh, absolutely. They're a lot of fun to play with. You can throw them in the air, they snap together, bring them back down. But in this case, we're using them in an industrial environment.
Okay.
And magnets are a little bit different than your normal gripping. So if you take a traditional gripper, like a parallel gripper or angular gripper, I can mathematically figure out what size gripper I need to handle a customer's part.
And what force you need to be able to grab.
Force I need. I have a lot of experience with that, and I really know. It's a defined thing that we understand. Magnetic gripping is a little bit different than that. We can make some mathematical calculations, but in the end, it's going to depend on metal thickness. It depends on the strength of the magnet and the type of the magnet. And in most cases, it requires us to do testing. Well, the CoLab allows us to do testing on customer parts that they send in here, and we can give them back a report and let them know how it performs.
So we're talking about metal thickness. So here we have a robot. We can see here, there's multiple thicknesses that we can pick up. We have a larger thickness, we have a smaller one. In fact, even over here, we can see that the robot can come in and grab 3 smaller components all at once. So the tooling here can either grab 1 plate, 2 plates, or 3 plates, deciding on what is needed to be grabbed. And that's just something air typically couldn't do. You would only grab that top plate.
If you're using vacuum, you can only pick up 1 piece at a time. With magnetic gripping on these parts, we can pick up a single piece, a double piece, or triple. So yes, this particular magnet runs on operates on 24 volts. It has 4 levels of power, so we can set it on low, medium, or high. and we can adjust it to pick up multiple parts.
So you said 24 volts, that's a big thing. And some applications, we don't need an external power supply to be able to handle this. It's automatically to go in. I can program it from a typical robot and leverage what I want to do that.
Exactly. No air is required. Everything is electric on this. So you have 24 volts, which is a real advantage for most manufacturing operations that can't use higher voltage.
That's great. Awesome. And this is a really unique application. So not only for machining, but also just for other application processes, I can select what type of components I want to grab with these.
Yes, that's right.
Very good.
All right, keep in mind that magnets are also very flexible.
Yeah.
So if you have different size or different shape parts, you can pick up multiple different parts with the same magnet and not have to change tooling, which can be an advantage. Another advantage is that you can work on 5 sides of the part of the magnet. So if you have a typical clamp or a gripper, you're blocking 3 sides of that and you can't machine it. With the magnet, you're gripping on 1 side and have access to 5. So there are definite advantages to using magnets.
Perfect. And that's the one thing that we can bring in here. We can reduce the risk out of a lot of applications by setting the components here. Can a magnet handle that process? And you can test that out before they do any type of integration or larger components to an automated piece.
Exactly. Not only do we reduce risk, but we have proof of concept. Now an integrator can take that concept to his customer and say, look, we've proven it out and we know it'll work.
Well, they can literally shoot a video here
Exactly.
and say, hey, here is your part being picked up with our gripper.
You're right.
Here it is, plain and simple, it worked.
And that's powerful.
Absolutely, especially in the industry where there's so many companies who are hesitant about automating because it could be a high risk. This could be the first collaborative robot that they purchase. They want to make sure that it works for them.
Exactly.
Perfect. Well, thanks so much for showing me this.
You're welcome. Thank you for stopping by. I'm going to introduce you to Brennan, who's going to talk to you a little bit about intelligent vision systems.
Awesome. Appreciate it. Thank you. Awesome. Brennan, how's it going?
Doing good. How about you?
Doing great. Well, the first thing I think we need to highlight here is you wrapped up the apprentice program here at Schunk. Is that correct?
That is correct.
So your journey started how many years ago?
So a little over 4 years ago, I started here at Schunk.
So, and you're part of the NC-TAP group. And really your journey, instead of going to a college to go get a 4-year engineering degree, you went through your apprentice program, you got paid along the way, and you decided to, you know what, I'm going to take vision and learn about it. So that's just kind of your journey leading up to here.
Yep.
That's fantastic. So like I mentioned, we're looking at vision here. This looks like a 3D vision system. What are we looking at?
So yeah, here we have a UR16 robot that has a gripper and a camera. So this is our smart graphing camera system. It is bundled together with this gripper here, so they work seamlessly.
Okay.
So here we're picking up a couple of parts and we're just dumping the parts out. So they land randomly every single time.
Yep.
So no matter what random orientation, the camera then observes those, sees the grasp points, and automatically creates a path to each grasp point.
That's great. So we're looking at randomized bin picking. And the one that's you think about this is when I have my gripper known to the robot into the program, I'm doing a couple of things. I'm reducing collision avoidance of my bin itself, and so I'm not going to run into the edges. I'm reducing collision of my end of arm tooling, or in this case, my gripper, because my vision system automatically knows what gripper I'm using, the orientation, the position of it, especially if I had components here that were at a weird orientation or we're standing straight up instead, I can adapt to that. So I can go into here and I can pick, 1, 2, 3, 4, 5 different pre-programmed risping techniques, and the vision system will determine what is the optimal pick.
That's right.
From that area. So that's just the big thing as well. When you're looking at a lot of systems that necessarily what we looked at over here can't be pre-stacked or pre-cartridged up to be machined, we can still do really cool post-processing machining or material handling of components, leveraging vision technology to then continue that operation.
That's right.
Very cool. So the one thing about this, we're looking at 3D vision. So we're looking at multiple cameras, being able to determine where our components are in the field. One other thing I think is really unique about this is it's a system that's tied in together. So an end user or a systems integrator can go in, tie in with the robot, tie in with the vision system, tie in with the gripper as one pre-programmed package. And you're not having to worry about taking all of these different vision systems and grippers and robots and trying to get them to all to work together. It's already pre-designed.
Right.
That's fantastic. Well, thanks so much for showing me this technology.
Yeah, no problem.
Perfect. All right, so I think we're going to have to move over here now And joining me again is once again Milton and Tom. So this was a really cool opportunity to come out here and see this going into CoLab. Thanks so much for bringing me out here.
Jake, thanks for being here. We just saw 6 technologies, and I think the thing that probably excites me the most is next time you're here, there's going to be also a lot of customer parts in this lab.
That's great.
It's an extension of our technology center and our training center, and I think this is the perfect extension to kind of address some of the numbers that you mentioned along the way. And those are some staggering numbers. We're talking about open jobs, and maybe 315,000 robots working in the US seems like a very large number, but I think we have to look at the density currently in the United States. It's 255 robots to every 10,000 employees. We have a ways to go.
We do. And that's the one thing that we're looking at here. These robots are addressing industry problems. And really what we're happening is for a long time, we were always able to automate large amount of products below SKU density. A lot of, we weren't able to touch the variation of components that we're wanting to automate. And here we're seeing the direct opposite of that. Now we can do a wide variety of components that are lower value and still be able to use automation solutions to leverage. I mean, that's the one thing that I liked about this. A couple of my takeaways were definitely the magnetic gripper, being able to grab a variety of components and be able to adapt to what your product is. And then the deburring one, I think, was the highlight and takeaway for me, this idea of an operator who 8 hours a day is going in there doing deburring. There's no enjoyment out of that. I can leverage automation to take that operator and do something more purpose-driven within their company.
And Jake, a lot of times that same operator is a skilled employee. If it's a CNC machinist,
Yeah.
they're gauging, they're writing code, they're doing high value work all day long. And for them to stop, to have to load a vise or to do something else that is mindless work, that's much less efficient. And that's what keeps us from going ahead.
Yeah. Let the robots work and the humans rule, and that philosophy is what's really important to leveraging automation.
I really like that one. I think I'm going to use that takeaway, Jake. Let the robots work.
Absolutely. And shout out to Plus One Robotics for doing that. That's their model. So I absolutely love it. So we're in a CoLab. We're here to focus on collaboration, not just collaborative robotics, but collaboration as well. Tom, how can companies who are watching this now, or distributors or other people, how can they collaborate with this lab?
Well, it's interesting today. We're at the same time of launching our CoLab. We're also having our first partner training starting today that since the onset of the pandemic. So we've had about a 2-year lull, and we have a lot of our distribution partners here today, and which is a very strong network. So no matter what town that you're in, you probably have somebody close by to you that's a Schunk expert, whether they're a direct employee or one of our blue level distribution partners. I strongly recommend you reach out to one of them. They can help you get in touch with Brennan or one of our other CoLab technicians or one of our applications engineers, experienced applications engineers here today that can get you on the way solving problems.
That's fantastic. And both of you, congratulations on kicking off the US CoLab. So exciting, just coming out of a pandemic and really just encouraging this once again, collaboration and cooperation with the industry that manufacturers and solution providers are working closer than ever in spaces like this.
Jake, thank you for making the trip here. Thanks to everyone for bringing these applications to us. It's been pretty exciting so far, and we're looking for a few more exciting days.
Perfect. Thank you guys so much. Appreciate it.